What's shaping up to be one of the most complex winter storm forecasts we've tackled this season. Massive changes in the afternoon model runs, especially for the eastern United States. We're going to break down the central U.S. situation first, then shift our focus to the eastern seaboard, and then we'll geek out a bit about the atmospheric dynamics that are making this such a challenging forecast. But I've got to tell you, this setup has kept me glued to the computer screen all afternoon. Winter storm watches and warnings are now posted across a remarkably broad swath of the country. Let me walk you through what's been issued and where. Starting in the central U.S., we've got winter storm watches extending all the way from San Antonio, Texas, transitioning into extreme cold warnings as you move northward through Dallas-Fort Worth, Oklahoma City, Tulsa, Little Rock, and Memphis. These watches then push northeastward into Nashville, Louisville, Cincinnati, and Charleston, West Virginia, extending all the way into the D.C. corridor. Now, on your screen, if you're looking at the watch and warning map, the teal color represents winter storm watches, pink zones indicate freezing rain warnings, and purple areas show ice storm warnings. For Texas specifically, watches cover San Antonio, Austin, Waco, Tyler, Longview, Dallas, Fort Worth, and stretch up into the Texarkana area. Oklahoma sees watches for Oklahoma City, Tulsa, Norman, and Lawton. Arkansas has Little Rock, Fort Smith, Fayetteville, Jonesboro, and Pine Bluff, all under winter storm watches. Louisiana's northern tier, including Shreveport, Monroe, and Alexandria, also falls under these watches. Mississippi has Jackson, Tupelo, and Meridian in the watch zone. Tennessee sees Memphis, Nashville, Knoxville, Chattanooga, and Clarksville all included. Kentucky has Louisville, Lexington, Bowling Green, Owensboro, and Paducah under watches. Missouri rounds out the central U.S. with Kansas City, St. Louis, Springfield, Columbia, and Joplin, all in the winter storm watch area. Now let's talk about what the models are showing, because this is where things get fascinating and, frankly, a bit frustrating from a forecasting standpoint. The European model and the GFS are showing two fairly different solutions, and I think the truth is going to end up somewhere in between these extremes. Let me be clear about something up front. We're still trying to iron out critical details on timing, precipitation-type transitions, and exact snowfall amounts. But here's what we're looking at. The European model is showing low-pressure tracking right up the Tennessee Valley. This is what meteorologists call a Miller B setup. What happens atmospherically in this scenario is fascinating. The low pressure brings warm air to the surface across Alabama and Mississippi. But here's the critical piece. Cold air is locked in place east of the Appalachian Mountains. This creates what we call cold air damming. That cold air just sits there, trapped against the eastern slopes of the mountains, and it doesn't budge. Meanwhile, warm, moist air from the Gulf of Mexico tries to override that cold air mass. This is classic overrunning, and it's a recipe for significant icing. The GFS model, on the other hand, is taking the low pressure on a slightly different track, further south and faster. It's not showing quite the same degree of cold air damming. The GFS solution would mean less freezing rain for areas like the Carolinas and Virginia, but potentially more for Arkansas and Tennessee. These look like two extremes to me, and I'm not fully convinced by either model run at this point. I think we're going to see something that splits the difference. Let me explain the color coding you'll see on these precipitation maps, and I'll repeat this several times as we go through different regions because it's critical to understanding what we're forecasting. Blue is snow, pink is freezing rain, orange is sleet, green is plain rain. These aren't just different colors for fun. They represent completely different hazards and impacts. Let's dive into the timeline for specific cities. And I want to be as detailed as possible here because the timing matters enormously for this system. Starting with Texas. Dallas-Fort Worth, you're looking at precipitation beginning Friday evening around 6 p.m., starting as snow initially. By midnight, Friday night into early Saturday morning, we're expecting a transition to sleet and freezing rain. Peak intensity hits Saturday morning between 8 a.m. and noon. The European model shows this continuing through Sunday morning, but the GFS is drier and faster, wrapping things up by Saturday evening. Houston, you're on the southern edge of this. Light freezing rain is possible Saturday morning, primarily north of the city. San Antonio starts Friday afternoon around 3 p.m., with a rain and sleet mix, transitioning to freezing rain Friday night. This continues through Saturday morning with peak intensity Saturday dawn. Austin sees a similar timeline to San Antonio. Waco, Tyler, and Longview all start Friday evening with snow, transitioning to sleet and freezing rain overnight. Lubbock and Amarillo in the Panhandle see mainly snow Friday night into Saturday, with accumulations of 6 to 10 inches possible. Corpus Christi and Beaumont stay mostly rain, but a brief period of freezing rain is possible very early Saturday as temperatures drop. Moving to Oklahoma. Oklahoma City begins Friday evening around 7 p.m., with snow, quickly transitioning to sleet and freezing rain by 10 p.m. This continues through Saturday afternoon. Tulsa sees a very similar timeline, perhaps starting an hour later. Norman and Lawton follow the Oklahoma City timeline closely. Arkansas is where things get particularly nasty on both models. Little Rock starts Friday evening around 8 p.m., with snow, transitioning to sleet by 10 p.m., then to freezing rain after midnight. This freezing rain continues through Saturday and potentially into Saturday night. We could be looking at significant ice accumulations here. Fort Smith sees a similar setup, perhaps starting 2 hours earlier. Fayetteville in northwest Arkansas gets more snow initially before the transition. Jonesboro and Pine Bluff follow the Little Rock timeline. Louisiana's northern parishes are in for a difficult time. Shreveport begins Friday night around 9 p.m. with sleet and freezing rain. This continues through Saturday. Monroe sees the same timeline. Baton Rouge and New Orleans stay mostly rain, but there's an outside chance of a brief freezing rain period very early Saturday morning if temperatures drop as much as the European model suggests. Lafayette and Alexandria are right on the borderline. Mississippi faces significant icing. Jackson starts Friday night around 10 p.m., with sleet transitioning to freezing rain, continuing through Saturday and possibly into Sunday morning. Gulfport and Hattiesburg on the coast stay mostly rain. Tupelo and Meridian in northern and eastern Mississippi see prolonged freezing rain Saturday into Saturday night. Tennessee is ground zero for this system on the European model. Memphis begins Friday evening around 7 p.m., with snow transitioning to sleet by 9 p.m., then freezing rain after midnight Friday night. This freezing rain continues through Saturday and Saturday night, with potential ice accumulations of 0.5 to 0.75 inches. That's catastrophic ice storm territory. Nashville sees an almost identical timeline. Peak intensity is Saturday morning through Saturday afternoon. Knoxville starts later, around midnight Friday night, with sleet and freezing rain continuing through Sunday morning. Chattanooga and Clarksville follow the Nashville timeline closely. Kentucky faces prolonged winter weather. Louisville starts Friday night around 11 p.m., with snow transitioning to sleet, then freezing rain Saturday morning. This continues through Saturday night. Lexington sees a similar timeline, perhaps an hour later. Bowling Green, Owensboro, and Paducah all start Friday evening and continue through Saturday night. Missouri sees significant impacts. Kansas City begins Friday afternoon around 4 p.m. with snow. This is all snow for Kansas City, continuing through Saturday morning with accumulations of 8 to 12 inches possible. St. Louis starts Friday evening around 6 p.m. with snow, transitioning to sleet and freezing rain overnight. Springfield sees mainly snow Friday night into Saturday, 6 to 10 inches. Columbia and Joplin follow similar patterns to Kansas City and Springfield, respectively. Now let's shift to the eastern U.S., where the forecast gets even more complex. Illinois faces a snow to sleet to freezing rain transition. Chicago starts Friday night around 10 p.m. with snow, transitioning to sleet Saturday morning. Accumulations of 4 to 8 inches of snow before the transition. Springfield and Peoria see mainly snow, 8 to 12 inches. Rockford in northern Illinois could see 10 to 14 inches, all snow. Champaign follows the Springfield timeline. Indiana is right in the transition zone. Indianapolis starts Friday night around midnight with snow, transitioning to sleet Saturday morning, then possibly freezing rain by Saturday afternoon. Fort Wayne sees mainly snow, 8 to 12 inches. Evansville in southern Indiana gets sleet and freezing rain Saturday. South Bend and Bloomington follow the Indianapolis timeline. Ohio faces significant winter weather. Columbus starts Saturday morning around 2 a.m. with snow, potentially heavy at times, transitioning to sleet by Saturday afternoon. Cleveland sees snow beginning Saturday morning around 4 a.m. continuing through Sunday morning with 10 to 16 inches possible. Cincinnati gets a messy mix starting Saturday morning, with snow, sleet, and freezing rain all in play. Toledo and Dayton follow the Columbus timeline. Akron sees heavy snow, 12 to 18 inches possible. Michigan is looking at heavy snow. Detroit starts Saturday morning around 6 a.m., with snow continuing through Sunday morning. 8 to 14 inches expected. Grand Rapids could see 12 to 18 inches. Lansing and Ann Arbor follow the Detroit timeline. Wisconsin sees all snow. Milwaukee starts Saturday morning with snow continuing through Sunday. 10 to 16 inches possible. Madison could see 12 to 18 inches. Green Bay sees 8 to 14 inches. Now let's look at the Southeast, where the European model has been showing some wild solutions. Georgia is right on the edge. Atlanta has an outside chance of seeing sleet and freezing rain Saturday night into Sunday morning, but this is highly uncertain. The European model is more aggressive with this. The GFS keeps Atlanta mainly dry. Augusta, Savannah, Athens, and Macon all have low probabilities of winter weather, but it's not zero. North Carolina is where the European model really goes crazy. Charlotte could see snow beginning Saturday night around 10 p.m., continuing through Sunday morning. The European model shows 4 to 8 inches possible, but the GFS has Charlotte mainly missing out. Raleigh, Greensboro, Durham, and Winston-Salem all have similar uncertain forecasts. The European wants to bring snow, the GFS is much drier. Asheville in the mountains could see 6 to 12 inches if the European solution verifies. Fayetteville follows the Raleigh timeline. South Carolina faces the same uncertainty. Columbia could see snow Saturday night into Sunday morning on the European model, 2 to 6 inches possible. But again, the GFS is much less impressed. Charleston, Greenville, Spartanburg, and Rock Hill all have low confidence forecasts. Virginia sees winter weather beginning Saturday night. Richmond could see snow beginning Saturday night around midnight, continuing through Sunday morning. 4 to 8 inches possible on the European model. Virginia Beach and Norfolk see mainly a miss. Roanoke in the mountains could see 8 to 14 inches. Lynchburg and Charlottesville see 6 to 12 inches possible. West Virginia gets significant snow on both models. Charleston starts Saturday afternoon with snow continuing through Sunday morning. 10 to 16 inches expected. Huntington, Morgantown, and Parkersburg all see heavy snow, 8 to 14 inches. Maryland and D.C. Metro face significant impacts. Baltimore starts Saturday evening around 8 p.m., with snow continuing through Sunday. 6 to 12 inches possible. Frederick and Hagerstown could see 8 to 14 inches. Washington, D.C. starts Saturday night around 10 p.m., with snow. 6 to 10 inches possible. Arlington and Alexandria follow the D.C. timeline. Delaware sees winter weather. Wilmington starts Saturday night with snow, 4 to 8 inches. Dover sees similar amounts. Pennsylvania faces a major snowstorm. Philadelphia starts Saturday night around 11 p.m., with snow continuing through Sunday afternoon. 8 to 14 inches possible. Pittsburgh sees snow beginning Saturday afternoon, continuing through Sunday morning. 10 to 16 inches expected. Harrisburg could see 12 to 18 inches. Allentown, Erie, and Scranton all see significant snow, 8 to 16 inches, depending on exact track. New Jersey gets heavy snow. Newark and Jersey City start Sunday morning around 2 a.m., with snow continuing through Sunday evening. 10 to 16 inches possible. Trenton sees 8 to 14 inches. Atlantic City on the coast sees 6 to 12 inches. New York faces a significant winter storm. New York City starts Sunday morning around 4 a.m., with snow, potentially heavy at times. 8 to 14 inches possible for the 5 boroughs, higher amounts north and west. Buffalo could see 12 to 20 inches from lake enhancement. Rochester sees 10 to 16 inches. Syracuse could see 14 to 20 inches. Albany sees 8 to 14 inches. Connecticut and other New England states see significant snow. Hartford starts Sunday morning with snow continuing through Sunday night. 8 to 14 inches expected. New Haven, Stamford, and Bridgeport see similar amounts, perhaps slightly less along the coast. Boston starts Sunday morning around 8 a.m., with snow continuing through Monday morning, 10 to 18 inches possible. Worcester could see 12 to 20 inches. Springfield and Cambridge follow the Boston timeline. Providence, Rhode Island sees 8 to 14 inches. Manchester and Nashua in New Hampshire see 10 to 16 inches. Burlington, Vermont could see 12 to 18 inches. Portland, Maine starts Sunday afternoon with snow, 8 to 14 inches. Lewiston and Bangor see similar amounts. Now, here's where it gets interesting. Let me geek out a bit about what's happening atmospherically, because understanding the dynamics helps explain why this forecast is so challenging. We've got low pressure tracking up the Tennessee Valley, that classic Miller B setup I mentioned earlier. This brings that warm nose of air aloft. Let me explain what that means. Picture the atmosphere in layers. At the surface, we've got Arctic air, temperatures well below freezing. But a few thousand feet up, temperatures are above 32 degrees Fahrenheit. So precipitation starts as snow up in the clouds where it's cold. As it falls through that warm layer, it melts into liquid water. Then it falls back through the cold air at the surface. If it has time to refreeze before hitting the ground, you get sleet. Those are ice pellets bouncing off everything. If it doesn't have time to refreeze but the surface is below freezing, you get freezing rain. That's liquid water freezing on contact with the ground, trees, power lines, everything. This is why the depth and temperature of that warm nose matters so much. A slightly deeper warm layer means more freezing rain instead of sleet. A slightly cooler warm layer means more sleet instead of freezing rain. Cold air damming east of the Appalachians is critical to this setup. Arctic air is dense and heavy. It settles into the valleys and against the mountains and just sits there like a lake. The mountains act like a dam holding that cold air in place. Warm air from the south tries to push in at the surface, but can't displace that cold air. So it rides up and over it. That's the overrunning I mentioned. This is why areas east of the Appalachians, places like the Carolinas and Virginia, can see prolonged freezing rain events, even when it's raining just 100 miles to the west. Now there's also northern stream energy diving down. This is separate from the Gulf moisture. Up in Canada, there's a strong jet stream dip, a trough of low pressure. Energy rotating around the bottom of that trough is going to dive southward into the eastern U.S. This could interact with the Gulf system, or it could be separate. The European model shows these two pieces of energy phasing together, which would create a much stronger storm system. The GFS keeps them more separate. If they do phase, we're looking at what meteorologists call bombing out, rapid intensification of the low pressure. That would mean heavier precipitation rates and potentially more snow for the mid-Atlantic and Northeast. There's also a deformation zone setting up where the northern stream energy interacts with the Gulf moisture. Deformation zones are where heavy snow bands set up. Think of it like wringing out a towel. The atmosphere is being stretched and squeezed, and moisture gets wrung out in narrow, intense bands. These can produce snowfall rates of 2 to 4 inches per hour. If one of these bands sets up over your location, you could see dramatically higher snow totals than areas just 20 miles away. The dry slot is another feature to watch. This is a gap in the precipitation where dry air wraps around the backside of the low pressure. Some models show a pronounced dry slot Saturday afternoon that would shut off precipitation for several hours before it cranks back up Saturday night. Other models don't show this feature. It makes a huge difference for accumulations. Let's look at the snowfall and ice accumulation maps, because this is where you can really see the differences between models. Remember, blue is snow, pink is freezing rain, orange is sleet. The European model has the main axis of heavy snow extending from southern Illinois through Indiana and Ohio, with a bullseye of over 12 inches, where Kentucky, Tennessee, Virginia, and West Virginia come together. Then it shows another bullseye across the Carolinas of 6 to 10 inches. The GFS is considerably further south with the heaviest snow. It has the main axis across Arkansas and Tennessee, with lower amounts further north. For the Northeast, both models agree on significant snow, but the European is about 4 to 6 inches higher with totals. For ice accumulation, and this is the really concerning part, the European model shows ice accumulations of 0.5 to 1 inch across a broad area from Arkansas through Tennessee into Kentucky. That's catastrophic ice storm territory. Power outages lasting days or weeks. Trees down everywhere, roads completely impassable. The GFS shows lower ice amounts, generally 0.25 to 0.5 inches across a smaller area. 0.25 inches of ice is significant and will cause power outages. 0.5 inches is crippling. 0.75 inches to 1 inch is absolutely catastrophic. Here's what's fascinating about the model disagreement. The European has been consistently showing this more aggressive solution for the past 3 or 4 model cycles. The GFS has been bouncing around more. Sometimes it shows a northern track with more snow for the Ohio Valley. Sometimes it shows a southern track with a miss for much of the Northeast. This inconsistency from the GFS makes me lean slightly toward the European, but I'm not fully convinced. So to recap what we've covered so far, we've got winter storm watches from Texas to Maine. We've got 2 different model solutions showing different tracks and different precipitation types for key areas. We've got the atmospheric setup with Miller B low pressure, cold air damming, overrunning, and potential phasing of northern and southern stream energy. And we've got potential for catastrophic ice accumulation somewhere in the central U.S. Now, what's the difference between the models when it comes to track? The European takes the surface low pressure right up through Nashville and Louisville. The GFS takes it further south through Memphis and Little Rock. That 100-mile difference in track makes an enormous difference in who sees what. A northern track means more snow for the Ohio Valley and Great Lakes, less ice for Tennessee. A southern track means more ice for Tennessee and Arkansas, potentially snow for the Carolinas. Why are the models different? It comes down to how they're handling that northern stream energy. The European is digging it deeper and slower. That allows more time for phasing with the Gulf moisture. The GFS is flatter and faster with the northern stream. Less phasing, weaker system, different track. Neither model is necessarily right or wrong at this point. They're both valid solutions based on slightly different interpretations of the initial atmospheric conditions. How far north does precipitation reach? That's another key question. The European extends significant precipitation all the way to the Canadian border. The GFS has a sharper cutoff around the Great Lakes. This matters enormously if you're in upstate New York or northern New England. You could either see a foot of snow or mainly miss out depending on which model is right. What about timing? The European is slower. It starts precipitation earlier Friday afternoon and continues it later into Sunday. The GFS is 6 to 12 hours faster with everything. Faster onset Friday evening, faster conclusion Saturday night. For planning purposes, assume the longer European timeline and you'll be prepared either way. This is the critical piece of information I want everyone to understand. The uncertainty in this forecast is not because we don't know if a storm is coming. We know a storm is coming. The uncertainty is in the details. Exactly where the heaviest snow falls. Exactly where the worst ice accumulates. Exactly how much precipitation each location receives. Those details matter enormously for impacts, but we're still 24 to 48 hours away from having high confidence in them. We're running out of time to figure out the exact details, but here's what we know with high confidence. Number 1. Winter weather is coming for a huge portion of the country starting Friday. Number 2. The central U.S. will see a prolonged period of sleet and freezing rain with significant ice accumulations, likely somewhere. Number 3. Heavy snow is likely for the Midwest and Northeast, though exact amounts and locations are still uncertain. Number 4. This is followed by bitterly cold temperatures that will make any ice accumulation last for days. Number 5. Impacts will be severe and long-lasting for areas that see significant icing. What I cannot tell you with high confidence yet is exactly where the heaviest ice falls. Is it centered on Memphis and Nashville, or does it extend further east into the Carolinas? I cannot tell you exactly how much snow falls in Philadelphia or New York or Boston. The range is still too wide. I cannot tell you if the Carolinas get buried in snow or mainly miss out. That's still a toss-up between models. This could easily shift northward, which would mean less ice for Tennessee and more snow for the Ohio Valley and Great Lakes. It could shift southward, which would mean less for the Northeast and more for the Carolinas. The timing could speed up or slow down by 6 to 12 hours. All of these are still in play. For those of you in the potential impact zone, now is the time to prepare. If you're in an area under winter storm watch, take it seriously. Stock up on essentials. Charge devices. Have alternative heating sources ready if power goes out. Fill prescriptions. Get cash. Fill up vehicles with gas. Have food that doesn't require cooking. This is especially critical for areas in the ice zone. Power outages could last a week or more in some locations. The temperatures following this system are going to be brutally cold. We're talking single digits for morning lows across much of the central and eastern U.S. Where you have ice on the ground and no power, temperatures in the single digits become dangerous very quickly. Wind chills will be below zero across a huge area. This isn't just uncomfortable cold. This is dangerous cold. Pipes will freeze, cars won't start. Frostbite becomes a concern in minutes, not hours. Let me paint you a picture of what a 0.75-inch ice accumulation means. Every surface outside is coated in 3/4 of an inch of solid ice. Tree branches that normally hold up fine under snow can't handle that weight. They snap. Power lines sag and break. Transformers explode. Roads become ice skating rinks. You can't walk outside without falling. You can't drive anywhere. Emergency services can't reach you. And this ice doesn't melt when it's in the single digits. It stays for days or weeks until temperatures get back above freezing for a sustained period. The areas most at risk for this level of icing are Tennessee, Kentucky, Arkansas, and possibly southern Missouri. If the European model verifies, Memphis, Nashville, Louisville, and Little Rock could see catastrophic impacts. But if the GFS is right, the worst ice stays further south in Mississippi and Louisiana. We'll know more in the next 12 to 24 hours as models hopefully start converging. For the Northeast, this is shaping up to be a classic nor'easter-type snow. The question is intensity and exact track. A track 50 miles further east means New York City gets 4 inches instead of 12. A track 50 miles west means Boston gets 6 inches instead of 16. We're watching the latest model runs very closely for any shifts in track. I'll be back tomorrow morning with fresh model data, and we'll see which solution the models are converging toward. If they start agreeing, that will give us much higher confidence. If they continue to diverge, we'll talk about the different scenarios and what each would mean for different areas. There's also another potential winter storm time frame next weekend we need to discuss. Very early signals suggest another system could affect some of the same areas around February 1st through 3rd, but that's still too far out for details. If you'd like a specific forecast for your city and I didn't mention it, or if you want more detail on timing and snow amounts, leave it in the comments and I'll answer individually as time allows. I try to get to as many as I can, though with a storm this size affecting so many people, it may take me a while. This is the kind of complex winter storm forecast that keeps meteorologists up at night. Multiple precipitation types, model disagreement, huge impact potential, a very compressed time frame to figure things out. We're going to work through this together over the next few days. I'll keep you updated as the forecast evolves. If you found this breakdown helpful and you want to stay updated on this evolving situation, subscribing to the channel would be appreciated. We're going to be all over this storm from now through the weekend.